I'm in my program main here, and I want to jump into my I/O ladder. Alright, so what am I going to do? This is where I'm going to start pulling in my I/O and setting the actual controls for it. And as far as laying out my code in here, I'm going to put some things in different networks. As far as that goes, I'll segregate everything by digital input, digital output, analog input, and analog output. To start with, I think I'll go with digital output because I really don't need to do anything with digital inputs in here. Those are going to be evaluated elsewhere throughout the program logic. So in here, I don't really need to alias these, or I don't need to set them equal to other registers or anything like that, because it's real easy to change I/O in this environment anyway. So let's go ahead and start with digital outputs, and I'll need a way to control those. So what digital outputs do I have? The first one that comes to mind is my oil pump VFD. So let's set an assignment for that. You're not going to see me using latches in ladders. And I've already copied that name, so I'm just going to paste that here. Oil pump VFD energize. And that should be _out. There we go. So let's just take it right out of that. Now, when are we going to energize this? Well, remember, we're going to be using HOA controls. We want this to come on when we're in hand mode or when we're in auto mode and the process demands it. But for right now, we're not doing HOAs yet, so I'm going to leave this open. And the way that I'm going to set these up now is that it's just going to always be energized. Obviously, that's not what we want, but what I'm doing now is really just laying out my I/O within the program, so not a big deal. The next one that I'm going to need, let's go ahead and create another branch down here, which is going to actually be a rung. And we're going to take another assignment, and I know we need to control our break, so that's going to be break _out. And another one, and that's going to be for our alarm horn. So let's bring in one more assignment, and that one's going to be alarm horn _out. We'll define that tag. That's going to be global memory bool. Done. And the next one is we've got our station interlock, and paste that in there. Station interlock out. Let's define the tag. That's going to be global memory bool define. Okay, so those are our 4 digital outputs. Now let's go down here and let's get to work on our analogs. And we've got analog ins and analog outs. Let's go ahead and start with our analog outs. So analog outputs. And first one that I know we've got is we're controlling our VFD. So we need to be scaling a signal out to our VFD. Well, while we're doing this scaling, I'm going to go ahead and set up a function block so that I can do my scaling in one block rather than use 2. So I'm going to create a new block, and this is going to be a function, not a function block. And I'll use function block diagrams for this, although you can use anything that you want. And I'm going to call this my SCP, scale with parameters. Hit OK. Got it. And let's come over here into conversion operations. And I'm going to want my scale X. And I'm going to want my normalize X, and I'll just attach that right there to the energize output. And we're going to have input _min, input _max, input _signal. That's all going to go out to TV, which is going to be a temporary value, and that's going to be what comes into here. we're going to have an output underscore min, an output underscore max, and then an SV scaled value. And this is going to be true all the time. And when this energizes its output, that's going to make this true. All right? So perfect. Let's define tag. This is going to be a local in of type int. Done. Define tag. Another local in, also an int. The same thing here. Local in int. This guy is going to be a local temp, and it's going to be real. Going back to local ins that are ints. And one more here. Local in int. And then right here, this is going to be a local out. And oh, it won't let me make that an int, and I know why, because I've got the wrong block here. So let's change that to a scale x. That's better. Now, define tag. This is going to be a local out and int. Done. And let's go ahead. It's not auto configuring that, so let's go ahead and tell that that's a real. Okay, so now we've got our function block set up to do our scaling. We can go ahead and close that and start using that to handle some of our outputs. So let's drag that function down here, put it right in there, and the first thing that we want to do is we want to set our VFD out. So I copied that value, and there we go. That's oil pump VFD SP underscore out. And now we just need to create the scaling for that. So the output, we know what we're going to be sending out. That's going to be our 0 to 27 648. All right, and that's our analog value that we get out of our, input output module manuals. So that's going to be our scaling figures that we're going to send out to that module to tell this thing what to do. And as far as our processing in the system goes, we're not sure what values we're going to end up using at this point, but I'm just going to set it up real simply and say we're going to treat that as a 0 to 100%. And then our input signal, what we're actually using inside of the program to decide what to send out to that, we can call that kind of anything we want. So I'm going to call this oil pump VFD SP underscore PCT, and that's percent. And right click, define that tag. That's going to be global because I know I'm going to be looking at that in other places, and I'll leave that as an int. Okay, so somewhere in the program, we're going to determine how much oil output we need on a scale of, at least for now, it's set at 0 to 100%. And we're going to be rescaling that to a value of 0 to 27 648 and shipping that out to our module. And let's go ahead and create another rung down here. Copy that, paste it. So now we've got the control again, and this time we're going to be setting up our baffle. So that's going to be baffle underscore out. That's going to be the value that we're writing there. We know that one is also going to be 0 to 27 648 output signal. And for an input signal, let's just call that baffle PCT. Good. Right click, define tag, and global memory int should be good. And I think those are the only two analog outputs that we have. So now let's come over here and one more network. That's going to be analog inputs. And we can go ahead and just copy one of those scaling blocks. Whoops, I didn't want to do that. Let's Control Z and Control V. Let's go ahead and paste that in here. And what's the first thing that we've got coming in? Off the top of my head, I know we've got our oil temp coming in, so that's going to be oil temp underscore in. And now we need to switch our values. So our input signal is going to be our 0 to 27648. And now our output is going to be according to the range of our sensor. And for this project, we've got it set up as a sensor that will read from 0 to 500 degrees. So 0 to 500, and we're going to save that as oil temp SV. Okay, so that'll be oil temperature scaled value. Or if we wanted to be really simple about it, we could just go ahead and call that oil temp. Whoops, it keeps giving me things I don't want. Oil temp. Okay, perfect. Right click define tag. That's going to be global memory. And do we want that to be an int? We could make that a real if we wanted to, but for this I say we keep it simple and let's make it oil temp. Okay, so let's give ourselves another branch here. Copy our SCP block and bring it down. What's the next thing we've got? How about our oil flow? Because we are working with oil, right? So oil flow underscore in and 0 to 27648. And then we want to scale that to 0 to 30 GPMs. And we will scale that out to oil flow and just make it real simple. So let's define that tag. Whoa, I don't know why it brought up that interface. Let's try that again. All right, perfect. Oil flow is going to be global memory int, and oil flow in is also going to be global memory int. All right, let's go down to our next rung here. Copy our block and paste it in. And how about we have, we're going to be measuring our RPMs. So let's take this RPM in and we'll output that to just RPM. Right click, define that tag. Global memory int, and we're scaling that from 0 to 200 RPMs. So that's going to be our output range on that. And the last thing I think we're looking at is going to be our current. So let's pull one more block in, paste it down here, and we will have an input signal of current underscore in. We're going to scale that from 0 to 700 kilowatts, and we'll save it as current. Doesn't get much easier than that. Define and global memory int, done. Our current in, define tag, that's going to be global memory int, done. Okay, so if I'm not mistaken and I'm not missing anything, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 pieces of I/O here, and I think that's everything that we need.